Welcome and thanks for joining us. My guest today is Dr. Bill Anderson, Principal Product Manager at Mattermost. Bill, thank you so much for joining me.
Morning, Terry. How you doing?
I'm great, thanks. We're going to talk about secure communications, and there have been some recent events that bring secure communication sort of to the top of our list. Sometimes events can move really quickly, and it can feel like getting to a skiff or getting on a secure network may take too much time. You need to respond right now. So, when you think about this, what are the essential components of a mobile secure network that moves at the speed of operations and events?
That's a very topical question. I think there are a whole bunch of people running around dealing with this issue today and over the last
Yeah.
couple of days. Um, I mean, the first thing is, particularly in the government context, we have to admit there are some things that are just too sensitive to be accessed outside of a skiff. And we more normal people are sort of blissfully ignorant of the level of interest and the seriousness of the techniques that adversaries will actually use to go and get government secrets. So, like to put this in context, so the folks that we serve at Mattermost in particular care about these things. This is not about protecting a view of your bank balance on your laptop at Starbucks. Like nobody cares that much about you. But when you're a military leader or a government executive, you can be assured that there are other countries thinking of ways to surveil you and to even create situations where you'd be tempted to shortcut those security protections. And so that's actually why those government rules are so stringent and frankly, inconvenient in a lot of cases. But the inconvenience, we work around it and you design systems to be able to do what is allowed in as secure a manner as possible quickly wherever the user happens to be. And that's outside of going and looking at a top secret thing. If you need to look at a top secret thing, you need to go to a skiff. But not everything's top secret. Um, so when you're doing your job, you're performing the mission, it requires that you handle information often. Uh, Failure to move quickly and failure to have the maximum context is actually a benefit to our adversaries. And that's where you need a secure collaboration system. So an incident comes up, you need to find out more detail, more context. You might need to involve more people quickly, and you need to do it sort of under a managed environment where we know because the adversaries are trying to listen in that we keep that data safe and secure. We need to think about, you're under pressure. So, do you know the identity of the other users that you're talking to? Where did those identities come from? They should come from the government. Right? The government, if you're talking to other government employees or you're talking to mission partners in other countries, there has to be a way to sort of control and update that basic information in your network infrastructure with the latest of permissions and clearances and so on. So you need a place to go to work where the essentials of who you're talking to and how you're talking securely have already been worked out. If you're doing this on an ad hoc basis and you need to make a phone call, it's probably bad planning. You shouldn't need to figure that out the day of the incident. So let's talk about a practical system for sort of large volume mission specific work. So there's hundreds and thousands of DoD and other government workers that go to work every day. What they need, number one, is a secure platform, a laptop, a desktop, somewhere that they can contact their peers, their colleagues, access data, move data around, create artifacts, and so on. They often also, though, need a secure mobile device. And these are, interestingly enough, often a BYOD device. There are government issued phones that are government managed, but the government doesn't buy a special phone for every single user that needs to do their job. I mean, there's hundreds of thousands of airmen and other folks in the DoD that have to access sensitive but unclassified, so CUI data all the time. And like I'm sure that the mobile phone companies would be happy to sell a custom phone to every single government worker, but that's just not something that's budgeted today. I mean, they don't have the extra tens and hundreds of millions of dollars that it would take to outfit everyone with those phones. So Instead, what government needs is a system that also enables control over that government specific information when it goes down to the user on their iPhone or their Android device. It still needs to be secure. And there's a way to connect policy with reality, right? So the reality is this is what's happening. And the policy says this can't happen. It's happening. It's happening anyway. And so how do you deal with that? Well, you put really, really stringent controls around that information before it goes down to the device. So you need to know, have I got biometric authentication of my users? Can I ensure that this device has not been jailbroken or rooted? Can I prevent screen sharing? Can I prevent video recording of stuff that's on the devices? Can I ensure that files are never downloaded? Do I know who my users are? Do I control the data at all points in time? And if we can do that, then when that emergency happens, we defeat the enemy by having better informational awareness, by having better situational awareness and getting stuff to the right people at the right time.
That is really interesting because I did not expect you to say that this could be a bring your own device solution. So, what has to happen on the back end? You mentioned some of those functionalities, but what is the state of cryptography and artificial intelligence on the back end so that that bring your own device approach seems seamless to the user so that, whatever their training might be, they're in the heat of the moment, they're not violating security protocols.
Yeah, the important thing again is preparation. When the emergency is started, it's too late. And so organizations who are incredibly responsible already with their information and they really do the right thing and they do plan in advance, what they typically do is they'll put these systems in place, they'll train their users, they'll get the workflows working. Um, in some cases, you can enforce mobile device management software. And what that does is it lets the government administrators, whoever they may be, it depends on the mission, have effectively some sort of containerized control on the mobile device. That means they can say, I can delete the device if I need to. I can delete the records. I can manage a little bit of that user's mobile device, even if the government doesn't control it. There are even those situations, though, where the budget or the infrastructure doesn't exist to put mobile device management on the endpoint. And what do you do in a case like that? Well, you still have, I mean, you can't just put up your hands and say, well, we can't control it. And so what our customers typically will do is they'll deploy a system with a lot of access control rules and other boundaries around that information so that it might be visible to specific users under specific conditions. So we basically are enforcing zero trust access control. So very, very granular, very, very dynamic, and kept up to date. So whether this user's got the right clearances today, what does their network look right? For example, like are they physically located in the state where we think that they should be? Maybe the rule says that in order to access this, you actually have to be on the base. Your operating system has to be up to date. You need to have the right clearance to see this. It has to be the right time of day, et cetera, et cetera. So we enforce zero trust access controls around information at an incredibly granular level so that we can let the users see the information that they want to work with, but not have the information. It goes into basically it goes from the Mattermost server to the user's brain because they can see it, but it doesn't sit around as an artifact for some adversary to try to go after. So um, that one of what I'm trying to describe is a system that requires preparation and planning, deployment of the server, and then definition of what those policy and access control rules are going to be. And so the challenge for our government customers is often to determine what they want their policies to be. There's a initiative from the DoD CIO to enforce zero trust on all DoD systems, and that's great. That we're 100% behind that. The next step down then becomes, but okay, what are the rules? I know I have to do it, but what am I supposed to do? And so we've put in place the system that lets them enforce those rules, whatever they may decide that they might be. So as I described, it might be a type of device, a certain person with a certain clearance at a certain time of day, and they have to be on the right network in the right physical location. Or it could be anything else, any combination of those things.
So, Bill, as I'm listening to you describe this, and I'm thinking all of the technological solutions that you've just described, put in place, the policies in place, sometimes in these events, the human is the weakest link in the chain. So, what happens when a human makes a mistake?
I've never heard of it, actually.
Never happens.
This is unheard of. Yeah, no, that's a very good question. It happens, of course. In fact, what generally happens, here's a really typical scenario. You have a file system or a sharing environment, a messaging system or a channels-based collaboration system where a whole bunch of us go to work. There could be hundreds of people working on a project, and we go to channels, right? I'm doing this. Please send me the document. We have a meeting. Have you done this? And there's a back and forth among all the hundreds of people that might be involved. And inevitably, someone puts a document that shouldn't be in that channel. It could be a floor plan for the facility. By the way, that's often above that cat. So that's not unclassified. That's often classified. The actual floor plan of a building. Or someone makes another mistake and drops something in there that shouldn't be there. What happens today is that that's actually a fairly catastrophic and expensive thing to happen. Um, the security folks, when they find out about this, are sometimes forced to literally go and burn the server down, and so delete it, and go around every one of the hundreds, maybe thousands of individuals who were in that channel and clean up their devices as well. So we're talking about potentially millions of dollars of expense and time used to resolve an incident like that. Wow, that's really expensive. So a better solution would be to nip that in the bud. So in our system, as an example, when someone makes a mistake, and it's inevitable that they will, anybody else in the channel, literally maybe the next person in, says, I don't think that file should be here. And they flag it. It gets removed immediately from the channel so no one else can see it. And then it goes off for security review with a data report, a metadata report of what happened, where it was, what's the content, and who might have seen it. And by being able to be really quickly reactive to those inevitable mistakes, I mean, people are people, it just happens, you can reduce the surface area of the problem. Maybe it was only 5 people that saw the file, and the file is now removed from the channel. The incident review team goes and looks at it. They might determine, yes, that was a bad file. It shouldn't have been there. But instead of having to delete the server and spend millions of dollars, they can go talk to the 5 people who saw the file, make sure their laptops are cleaned, make them sign a letter to the effect that they saw something they shouldn't have seen, and deal with it on a much more localized basis. So there are ways to deal with human error. Unfortunately, humans are infinitely capable of making new errors. So you do have to stay on top of it.
We're going to take a short break and then we'll continue this conversation with Dr. Bill Anderson, Principal Product Manager at Mattermost. Welcome back to a conversation with Dr. Bill Anderson, Principal Product Manager at Mattermost. Bill, in the first half, we were really talking about devices and the security and technology behind them to make sure that devices stay secure. But what complications arise when partners are using different communication systems and different security standards, maybe across agencies or even across countries?
Especially across countries, it's an issue because they don't call these things the same thing, and so their rules are different. And but even across different agencies, there are different rule sets and different ways of classifying things. So the default is no, you can't share it. That keeps everyone safe. Unfortunately, that's not the right answer. Sometimes you can. And so you need a proper setup where you have the ability to define what the policies are, and that requires sort of above and beyond thinking. So if we're working with a Five Eyes ally around some intelligence information, there's established mechanisms for deciding how to do that crossover, but then you need to enforce the policy on both sides. And one of the and this is never as simple as I want to look at one file once. More likely, this is a dynamic situation where there's new people coming in, there's new information coming in, things are evolving on the ground, more information is coming in. So you set up for a dynamic, very, very granular type of access control that is applied to the files, is applied to the people, it's applied to the channels, where you check every single time, is this person in the right trusted group right now that meets the policy to be able to share this file with, let's say, the UK as an ally, or the Canadians, or the whoever. Um, and that would be done custom on the basis of that mission and the sharing arrangement between the two. But it's a zero trust access control. I mean, again, meeting the DoD's standards, but the intelligence community and government requirements in general. Um, the point is, though, you really first need to have an authority that can set that access control policy. And that can be hard if they haven't done it before. A lot of this has been done, but putting it into words and putting it into, a common expression language for what it means to do sharing across these different boundaries, that takes a little bit of technical work. We built it into our products so that we can have two independent servers, and data sovereignty really plays into this. That's another point. Who owns the data? It might have originated with the United States, or it might have originated with the allied partner. And so they own those original documents. When they start to collaborate in a channel or create new artifacts, who owns that and who controls it? And so you have to think about independent servers that are able to collaborate with each other cross border, and still maintain sort of independent controls of the documents and so on that are protected. Also, the different countries might have different um, rules around how to maintain records of these conversations. You can also have toolchain incompatibility, where the formats are different, or the systems for archiving are different. And so by distributing it across two separate servers that have a federated connection with each other, you can allow both organizations to sort of meet their internal standards. It's complicated, but it's absolutely feasible if you have the will to define those policies.
Bill, can I follow up on your data sovereignty point? Because it occurs to me we're talking about collaboration between two sovereign governments, but oftentimes isn't some of this data going to be owned by corporations in the private sector? And how do you integrate them into a governmental secure communications chain?
Yes, so often we do have those kinds of interactions. And fortunately, the policies might be different, but the technical approach is the same. Uh, Someone defines the policies, and it might be, for example, I need to do a cross-domain, or from a classified to an unclassified sharing arrangement. There's very strong technical filters, they're called cross-domain systems, that can prevent accidental sharing of information from a high to a low. We would run our shared channels through our multiple servers through one of those sort of one-way diode or aggressive filters to allow those two organizations to collaborate without accidentally sharing the wrong data. And then each would keep their own records. So I might be, a specialist security company that's collaborating with a government agency around a particular incident. I can contribute up to the government through one of those filters. I maintain my channels of communication, some of them with the government, some of them internal. And I can archive and manage and do, administration on all of that myself. And on the government side, they can do to their requirements as well. So it's feasible. It gets a little bit more complicated, but the point is to choose your systems so that they're open to those kinds of integrations.
Eh, Complexity is the word that just overwhelms to me what you're describing. To have individuals with that level of responsibility and to make those sorts of plans seems incredibly complex. How should countries plan for that complexity? And maybe even further, how should they plan for such a complex system to be resilient?
Yes. One thing that's guaranteed is when the trouble hits, some of your networks will go down. And so a lot of our customers do think about these sort of denied environments where you have intermittent connectivity and plan accordingly. Now, interesting, story is governments are actually very, very good at this. The American government was, in fact, the originator of the concept behind the internet, and it was designed to withstand a nuclear attack. Well, when we deploy physical systems, we deploy them in mesh networks with redundant, reliable channels and the ability to resynchronize. So a typical when a Mattermost server goes down, it might not be available to local users for a while, but the backup servers are still working. And so users can continue to do their job, collaborate with their colleagues or whatever. And then when the first server comes up or the network comes up again, it will resynchronize all of those communications. And that's simply something we learned from that original ARPANET project of how to do redundant and resilient communications. Um, so government's actually very, very good at that. One of the challenges, though, becomes when they start to choose their software and their software partners. Um, Government off-the-shelf software, custom software. There is a risk early on in these projects that the systems integrator is doing the work or the vendor is trying to get lock-in, right? If you're trying to design the customer around a proprietary system, there's sometimes a short-term win in saying, oh, I've already got these other IT products. This new one will integrate with those. That's great. But how do you get new features later? Like let's say you want to add new data processing from a third-party system to your workflows. If you have to depend on one vendor to do this, how long do you wait? And how much do you pay? It's so for any of these government projects, they really need to think about choices that are going to let them choose new integrations and extend and expand the capabilities themselves or with a contractor in the future if some sort of new integration or new workflow or new brand new capability becomes important. And so what I'm really talking about is a modular and open architecture. We highly recommend agencies look at their long-term needs, even if they don't know what that is. They do know that at some point in the future, they might say, for example, oh, this new AI thing seems to be a big deal. It can help us to answer questions. It can be a resource to our employees. It can do a whole bunch of things. How would we add that with a sovereign, self-hosted AI model because of security requirements? How do we do that? You want to be asking that kind of question when you're making a choice about what your collaboration system looks like. So, and the answer should be, we could do it ourselves. We could hire someone else, or a third party could do it because there's something like an open standard existing already for connecting those things. So really, they need to make sure that they avoid lock-in, even if the short-term benefit is, oh, it already connects to our Active Directory system or something like that. That's nice, but you guarantee being slower, less capable, and more expensive in the long run if you don't think ahead.
Well, and you really need to think ahead because the adversary is working at a very fast pace, right?
In fact, that's another area to think if you're, and so we talk about a new topic, think about security. Start thinking about post-quantum cryptography and future-proofing the protocols, the security protocols that you're using. What that means is that there are quantum computers that are under development. They're getting bigger and better all the time. At some point within the next 10 to 30 years, and experts are uncertain as to when, those quantum computers will be able to break the encryption that we are all using today. As you and I talk, we're talking over a TLS 1.3 protocol that's using probably elliptic curve as the public key exchange mechanism. Doesn't matter if you don't know what that means. It will be broken in the next 10 to 30 years. And that's fine for our conversation. But if you're protecting government secrets, that's not okay. And so you need to start thinking about that too.
Bill, this has been a fascinating conversation. Thank you so much for joining me today.
Thanks, Terry.
My guest today has been Dr. Bill Anderson, Principal Product Manager at Mattermost. I'm Terry Gerton, host of the Federal Drive on Federal Insights, sponsored by Mattermost on Federal News Network.